Chapter 21. Neurological and Systemic Symptoms. Neurological and systemic symptoms arise when the digestive sequence fails to deliver a stable supply of substrates and instead produces a variable internal environment that extends beyond the intestine. The brain and peripheral systems depend on consistent inputs of glucose, amino acids, fatty acids, and micronutrients delivered in a pattern that matches metabolic demand. When digestion is aligned, these inputs remain steady and predictable. When it is not, fluctuations in substrate availability, combined with changes in microbial output and immune signaling, propagate into the systemic circulation and alter how the body functions at multiple levels. The first layer of this effect is substrate instability. Incomplete digestion reduces the availability of usable nutrients, while irregular absorption creates uneven timing of delivery. The brain relies on a continuous supply of substrates to maintain signaling and energy production. When this supply becomes inconsistent, neuronal activity reflects that variability. Periods of adequate substrate availability are followed by periods of relative deficit, creating fluctuations in cognitive function, focus, and overall neurological performance. The system compensates, but the compensation introduces variability rather than restoring stability. Lipid-derived substrates play a central role in stabilizing neurological function because they provide sustained energy and contribute to membrane structure within neural tissue. When fat digestion and transport are aligned, fatty acids are delivered gradually, supporting continuous energy production and maintaining membrane composition. When lipid processing is impaired, this sustained supply is reduced, and the system becomes more dependent on rapidly fluctuating carbohydrate-derived substrates. This increases variability in neuronal energy availability and affects signaling consistency. Microbial activity contributes an additional layer of influence by generating compounds that enter circulation when fermentation increases. These byproducts reflect the substrates that reach the distal intestine and the metabolic activity of the microbial population. When digestion is incomplete, increased fermentation produces a wider range of compounds that interact with the systemic environment. These compounds alter signaling patterns and contribute to changes in how the nervous system responds to internal conditions. Immune signaling links the intestinal environment to systemic responses. Increased exposure to incomplete substrates and microbial byproducts elevates signaling at the epithelial surface, and this signaling extends beyond the gut through circulating mediators. The result is a change in how the body regulates its internal state, affecting energy use, perception, and overall physiological behavior. This connection reflects the integration of digestive, immune, and neurological systems. Hormonal responses further shape these outcomes by reacting to the variability in substrate delivery. Fluctuations in nutrient availability alter signals that regulate energy distribution, storage, and use. These changes influence how substrates are directed toward the brain and other tissues, affecting both immediate function and longer-term stability. Neurological and systemic symptoms, therefore, represent the outward expression of an internal sequence that has lost consistency. They arise from fluctuations in substrate availability, changes in microbial output, and increased immune signaling, all of which originate from disrupted digestion. When the digestive sequence is restored and substrate delivery becomes stable, these downstream effects are reduced as the system returns to a more predictable internal environment. Brain fog, fatigue, inflammation. Brain fog, fatigue, and inflammation emerge from the same underlying condition, which is an unstable internal environment created by disrupted digestion and inconsistent substrate delivery. These are not isolated symptoms with separate causes. They reflect how the brain and peripheral systems respond when energy supply, molecular signaling, and immune activity are no longer aligned with the body's structural requirements. The digestive system sets the conditions, and the nervous system expresses the outcome. Brain fog begins with variability in substrate availability. Neurons require a continuous supply of energy substrates to maintain signaling. When digestion is incomplete or absorption is irregular, the delivery of these substrates becomes uneven. Periods of adequate supply are followed by periods where availability drops, forcing the brain to adjust its activity. These shifts alter how neurons fire, how networks coordinate, and how information is processed. The result is a reduction in clarity, slower processing speed, and a sense that cognitive output no longer matches demand. Fatigue develops from the same instability but reflects the system at a broader level. When substrates are not delivered consistently, cells across the body must adjust their energy production to match what is available. Mitochondria shift between fuels, alter pathway activity, and operate under changing conditions. This constant adjustment reduces efficiency and increases variability in energy output. The body compensates by reducing activity, conserving resources, and limiting output where possible. Fatigue is the expression of this constraint, not simply a lack of energy, but an inability to sustain stable production. Inflammation links these symptoms by responding to the internal conditions created by incomplete digestion. Larger food fragments and microbial byproducts increase signaling at the intestinal interface, and this signaling extends into circulation. The immune system reacts to the presence of these materials by altering its activity, producing a state where signaling is elevated and persistent. This state changes how tissues function, how energy is used, and how the nervous system interprets internal signals. Lipid processing plays a stabilizing role across all three conditions. When fats are properly emulsified, absorbed, and transported, they provide a sustained source of energy and contribute to the structural integrity of cellular membranes. This supports consistent energy production and stable signaling. When lipid digestion is impaired, this stabilizing influence is reduced, and the system becomes more dependent on rapidly fluctuating substrates. The variability increases, and the symptoms become more pronounced. The interaction between these processes creates a feedback pattern. Inconsistent substrate delivery alters energy production. Changes in energy production affect cellular function, and immune signaling modifies the internal environment further. Each layer influences the others, reinforcing the instability that produced the initial symptoms. Brain fog, fatigue, and inflammation therefore represent different expressions of the same underlying disruption. They arise when digestion fails to provide a stable and complete supply of substrates, when microbial activity shifts due to incomplete processing, and when immune signaling responds to the resulting environment. Restoring the digestive sequence changes the inputs to the system, and as those inputs stabilize, the downstream effects begin to resolve in parallel. Gut-brain signaling breakdown. Gut-brain signaling depends on a continuous exchange of information that reflects the state of digestion, the availability of substrates, and the condition of the intestinal environment. This exchange is carried through neural pathways, circulating metabolites, and immune signals that originate at the epithelial surface. When digestion is aligned, these signals are proportional to real conditions and allow the brain to coordinate appetite, energy use, and behavioral output with what is actually available. When digestion is disrupted, the signals no longer represent a stable internal state. The brain receives inconsistent inputs and responds to a system that is changing from moment to moment. The breakdown begins with variability in luminal processing. Incomplete digestion increases the presence of larger food fragments and shifts microbial activity toward fermentation. This alters the profile of compounds generated within the intestine. These compounds enter circulation or interact with neural pathways embedded in the gut wall, changing the signals that are sent to the brain. The pattern becomes irregular because it reflects inconsistent processing rather than a controlled sequence. Neural signaling through the gut is highly sensitive to mechanical and chemical conditions. Distension, pressure, and the composition of luminal contents all influence how signals are generated. When motility is coordinated and substrates are properly processed, these inputs remain within a narrow range. When digestion is incomplete, gas production increases, pressure fluctuates, and the physical state of the intestine becomes more variable. Neural signals track these changes, transmitting a pattern that reflects instability rather than balance. Circulating signals add another layer to this breakdown. Substrates that are absorbed enter the bloodstream and influence how the brain interprets internal conditions. When absorption is consistent, these signals provide a reliable representation of nutrient availability. When absorption is irregular, the signals fluctuate, and the brain must respond to changing conditions. This affects how energy is allocated and how behavior is regulated. Immune signaling integrates with both neural and circulating pathways. Increased exposure to incomplete substrates and microbial byproducts elevates activity at the intestinal interface. This activity generates signals that extend beyond the gut, altering the overall signaling environment. The brain interprets these signals as part of the body's internal state, adjusting its output accordingly. Lipid transport influences gut-brain signaling by shaping the timing and persistence of substrate delivery. When lipid digestion and transport are aligned, fatty acids enter circulation in a sustained pattern that supports stable signaling. When this process is impaired, the system becomes dominated by more rapidly fluctuating inputs, increasing variability in how signals are generated and interpreted. Gut-brain signaling breakdown therefore reflects a loss of alignment between digestion and communication. Signals are still produced, but they no longer correspond to a stable or predictable internal state. The brain responds to this variability, adjusting behavior and physiological output to match inputs that are inconsistent. Restoring the digestive sequence reestablishes the conditions under which signals accurately represent internal reality, allowing coordination between the gut and brain to stabilize.